In exercise number 1, we're asked to graph this following piecewise defined function. Excuse me. And so the best way to do this, in my opinion, and the way that I've done it for quite a while now, is to take each of these pieces here and graph them out separately. So what I'll end up doing is I'm going to draw out the coordinate system. Okay. And then what I'm going to do is I'm going to use these back guys right here. They basically tell us the domain, the restricted domain for each of these functions. So what I mean by that is this x is less than 2 says that, okay, on our axis, okay, here's 2. Whenever the x value, which is this axis, whenever it's less than 2, so whenever it's on this side, and let me go ahead and draw that in here in yellow. So whenever it's over here, okay, we're going to see this function. Okay, this guy right here. Oops. So we're going to see x minus 3. You can think about it like you can do a table of values if you want to. You can just see what this, if you know what this graph looks like, you can just sketch it out. Okay. Then on when x is greater than or equal to 2, so at 2 and more than it on this side, we're going to see this guy right here. Okay. So all we're going to do is, what I do is I just basically, let me erase those lines there. Okay. So what I'll end up doing is for right now, I'll make a dotted line in here. Later I erase that, but I use this as like a boundary. And so over here is where I'm getting that 2 from. And I'm saying, okay, on this side over here, I'm going to see x minus 3. When x is greater than or equal to 2, on this side over here, I'm going to see x squared. So what some students like to do when they first start out is they like to make a table of numbers. So I'll make a little x, y chart, and I'm gonna do it over here for this function right here. So this is what y is equal to over on this side. So what I'll do is I'll start grabbing some numbers over here. I always use my division line, whether it's included or not, and I'll show you why in just a second. But I'll start with 2 here, and then I'll work my way backward with some values. And usually I'll just use the integer values because it's easiest. You can use whatever you want. So I started at 2, and then I used numbers that were less than that. So 2, 1, 0, so on and so forth. So that's my table. And I'll take each of these guys and I'll plug them into this function. And so 2 into here gives me negative 1. 1 into here gives me negative 2. 0 gives me negative 3. You get the pattern. So then I'll graph those out. I'll plot those out. Now, this one right here is the special one because it's on the division line. It's on the dividing line here. And we're not going to include it because this guy's got the including part. This guy doesn't. So I'm going to put an open circle at this point. So I'm going to go 2 over, down 1, and there's going to be an open circle there. So 1, 2, 3, 4, 5, 6, 7. Okay, and now for the rest of these guys, I'll just plot these out. So they're all going to be closed. So 1, negative 2, so 1 over, down 2. Now, of course, all the points in between here are also included, so we can connect these. And we should connect these. Okay, 0, negative 3, down here somewhere, negative 1. Okay, you guys get the idea. Okay, so I'm just gonna, there it is. So that's the yellow graph. And we're done with this side now. We don't have to do anything else over here. Now notice that I put an arrow over here because this graph continues on forever in this direction. If I just stop my line, that's not correct. Also, I do not put an arrow over here because we do need to stop at this point. Okay. Now what I'll do is I'll do this next one here. So when x is greater than 2, so on this side, greater than or equal to 2 on this side right here, we're going to graph this function. So we'll make a little xy chart. Okay, and so we'll say, okay, we need 2, 3, 4, 5, just to kind of get an idea of what's going on over here. So when I plug in 2 here, I get 4 out. When I plug in 3, I get 9. We're already going to be very high in the graph, okay? 4 gives us 16, 5 gives us 25. So at 2, let's do this. So there's 10 dashes right there. At 2, we're at a height of 4, so 1, 2, 3, 4. Closed circle, because we're including it. And then 3, we're up at a height of 9. Okay, at 4, we'd be up at a height of 16 way up here. So this guy is going to look like that. And of course, it keeps on going up, right? Try to make that look like it actually hits a little bit better. You get the idea. Okay, so it's going to come up in this direction, and that's it. So this dashed line is not part of the graph. It's just to help us see what's going on. And what you end up with down here, this is your graph, your function. Okay, and that's it. That's the piecewise defined function. And we're going to talk about, the reason these are important is they give us a nice tool for talking about limits. And so we're going to discuss, well, what happens as we approach 2 from, let's say, the left side and the right side as we come into 2. What's our function doing? Now, the second part of this question asks us, I'm going to erase this over here so I can do the second part. Second part asks us to determine the following. So f at -3, the function at 2, and the function at 5. There's 2 ways of looking at this. Probably the best way, in case you made a mistake down here, the best way is to go back and look at your original equations. Okay, but you don't have to. You can look at the graph. So I'm going to do it both ways. So at -3, the question is, this is the function f. Okay. So the question is, at -3, what height are we at? Well, when we go over to -3, we're clearly down here, and that's at -6. So the other way to do it is say, okay, where does -3 fall? Does it fall, and if you just draw out these 2 little intervals right here, it makes life a little bit easier. I'll get rid of that point. So this is 2. This guy is greater than or equal to 2. And this guy is strictly less than 2. And so the question is, where does -3 fall? On which line? Well, -3 falls on this top one, right? It's in this shaded area. So we plug -3 into here, and we get -3 minus 3, which is -6. Now let's try that same thing with 2. So which one does 2 fall on? Well, it doesn't fall on the top one because that's an open circle. It falls on the bottom one because that's closed. So we take 2, we plug it into this guy, and we get 4 out. The other way is same when we go over to 2, if we look up or down, where's our function? Well, it's not down because that's an open circle. It's up here at a height of 4. Now 5, where does 5 fall? Well, it falls on this one right here. And so since 5 falls here, we plug it into this function, and we get 25 out. It's not too bad. I mean, it's pretty straightforward. We'll go ahead and I've got another exercise here that we'll take a look at with 3 different functions, and we'll make sure that we really have a good understanding of this.